Hey guys, this is Test Prep Chapter 6, Number 2, so this is including everything from Chapter 6. Let's go ahead and get started. We have a total of 4 questions on the test from 6.1. There are going to be 3 from 1 through 12 and 1 from 25 to 30. But if you look at 25 to 30, it's very similar to what we have at the 1 through 12. But there is perhaps one that might stand out, that might benefit you to look at. Hint, hint. All right, so looking at the first 12, the first thing you need to do with these is to put them in order from least to greatest. And looking at number 11, we have 4x plus 5x squared plus 8. So we need to put it in standard form, and standard form tells us that we have to put the highest power first. So I'm going to put 5x squared plus 4x and then plus 8. Now this is an order, and then we classify it by the degree of the first term. So this is a quadratic. And then we classify it by the number of terms. There's 1, 2, 3. So that is a trinomial. Then we take a look at the next one, x squared minus x to the fourth plus 2x squared. Well, x squared and 2x squared are like terms, and negative x to the fourth is different. The fourth is larger power, so it comes first. We have negative x to the fourth, and then x squared plus 2x squared is plus 3x squared. We look at the power of the first term, and that is quartic. And then there is 1, 2 terms, so it is a binomial. Okay. All right, so now let's go ahead and take a look at the problems from 25 to 30. And I don't know about you, but number 30 really sticks out because it's the only one that is in fraction form, and we didn't have anything like that for the 2 through 12 part. So looking at number 30, you have 3x to the fifth plus 4x all over 6. This is the same as 3x to the fifth over 6 plus 4x over 6. And now we reduce, we simplify this. 3 and 6 have a like factor of 3, so that gives you 1 up here and then 2 down here. And 4 and 6 have a like factor of 2, which leaves you with 2 here and 3 here. Rewriting this, 1 times x to the fifth is just x to the fifth, and then in the denominator is 2, plus 2x all over 3. All right, and so that's a 5, a kind of sloppy 5, but a 5. All right, now we need to classify that by degree and number of terms. Well, the fifth power is larger than the first power, so this one is a quintic. And then there are 1, 2 terms, so it's a quintic binomial. All right, hopefully that's good. Let's go ahead and take a look at 6.2. Excuse me. There are a total of 4 questions that will be taken from 6.2. And the ones we are looking at, we have 2 from this 7 through 12 section. And we are going to write the polynomial in factored form. You do not need to check by multiplication, but it is a tool that you can use. All right, I am going to look at number 11. So we have x cubed plus 8x squared plus 16x. So the very first thing I want to do is factor out an x because each of these terms have an x. That leaves you with x squared plus 8x plus 16. Now we need to find factors of 16 that when we add them together would give us an 8. And so with 16, we know we have 1 and 16, 2 and 8, and 4 and 4. The only pair that would give us 8 in the middle is going to be the 4 and 4. So we bring this x down, and then we have x plus 4 and x plus 4. You may leave it perfectly like this. It's okay. You would get full credit. But you can also write that as x times the expression x plus 4 and then the quantity squared because you have 1, 2 of those same expressions. All right, let's take a look at 21 through 28. There will be one from this section, and it says write a polynomial function in standard form given the zeros. Let's take a look at number 26. So we've got -1, -2, -3. This means that I have a function equal to x minus a -1, which makes that x plus 1, x minus a -2 makes that plus 2, and x minus -3, which makes that plus 3. Now you can begin by multiplying any of the two expressions together, and because none of these stand out differently or it's easier or more beneficial, I'm just going to go ahead and do the first two. So x to x is going to give me x squared. X to 2 gives me 2x. 1 to x gives me x, and then 1 to 2 gives me 2. I'm going to bring this x plus 3 down so that I don't accidentally forget about it. And then I need to combine like terms, which gives us x squared plus 3x plus 2 times the expression x plus 3. I now need to distribute each of the terms in this trinomial to each of the terms of the binomial. So we have x squared to x, which is going to give us x cubed. X squared to 3, which is 3x squared. 3x to x is 3x squared. 3x to 3 is 9x. 2 to x is 2x. And 2 to 3 is 6. All right, and now I need to combine like terms. So we have 3x squared and 3x squared, and 9x and 2x. So then this is going to give us x cubed plus 6x squared plus 11x plus 6. And this would be your final answer. Okay. All right, one more question, and this one is going to be about finding the zeros and then stating the multiplicity of any multiple zeros. Looking at number 36, that one tends to be one that intimidates many. Since this is already factored, you can just go ahead and set each of these expressions equal to 0. So then you would have x plus 1 equals 0, x minus 1 equals 0, and x minus 2 equals 0. So solving this for 0, you would subtract 1 from each side. So this gives you, wait a minute, solving that for x, you would subtract 1 from each side, giving you x is -1. And then we add 1 for this one, so then x equals +1, add 2, so then x equals 2. These are the zeros. However, one of these expressions was repeated. We have x plus 1 squared. So then that means for that 0, we have a multiplicity of the power. So that would be in this case 2. Now, if you remember in class, I did tell you that you can expand that out. So then you have x plus 1 times x plus 1, and then write the x minus 1, x minus 2. And then you would set each of these expressions equal to 0. So then this one would give you -1. This one is -1. This one is 1. This one is 2. So then we have two that are -1, right? So then you would have -1 multiplicity of 2 because it happens twice, and then you have an 1 and 2. Same answer, doesn't matter how you get it. Okay. All right, moving on to 6-3. We have divide using long division, where there's one where you have to use long division, one where you have to use synthetic, and then the other one is evaluating an expression using the remainder theorem. Okay, so long division, let's take a look at number 8. Okay, so we have divide x cubed minus 13x minus 12, and we're dividing that by x minus 4. So x minus 4 goes on the outside, and then underneath my division bar, we have x cubed. There is no x squared term, so I'm putting in plus 0x squared. Then I have minus 13x, and then minus 12. In order to divide, I need to do something to this x to make it match x cubed. I completely ignore the negative 4 for the moment. So if I multiply x by x squared, then that would match the x cubed. So I'm going to multiply this by x squared, giving me x cubed. What I do to the first term, I have to also do to the second. So that would give me negative 4x squared. Now I'm going to subtract this expression from the one above, so this cancels, and then you have 0 minus a negative, which gives you 4x squared. We bring down the negative 13x. Now I look at this first term, and what do I do to x to make it match 4x squared? Well, in this case, I would multiply it by 4x. 4x times x, 4x squared. 4x times negative 4 is negative 16x. Now I subtract this expression from the one above, so 4x squared minus 4x squared cancels out. Negative 13 minus the negative 16, so negative 13 plus 16 gives me 3x. I bring down the negative 12. What do I need to do to my x to make it match 3x? Well, I'm going to multiply that by 3. 3 times x is 3x. 3 times negative 4 is negative 12. When I subtract this expression from the one above, I'm going to have just a 0. So that would be a remainder 0. So then my answer is x squared plus 4x plus 3. Okay, let's look at synthetic division, because we have a question from there. And I'm just going to do 21. So we have x cubed plus 27, divide that by x plus 3. Now with synthetic division, remember you have to find the 0 because they are giving you that expression instead of the root. So this then becomes negative 3. And then this one I need to rewrite. So we have negative 3 on the outside, that's our divisor. And then we have x cubed, the coefficient of x cubed is 1. The coefficient of the x squared term is 0, because there isn't one. And the x term is also 0. And then we have 27. I am going to begin by bringing my first term down. Negative 3 times 1 is negative 3. 0 and negative 3 is negative 3. Negative 3 times negative 3 is 9. 0 plus 9 is 9. Negative 3 times 9 is negative 27. 27 minus 27 is 0. This then is my remainder. This is the constant. This is my linear term, and this is the quadratic. So I rewrite this as x squared minus 3x plus 9. And this would be my answer. Okay, I'm going to go ahead and pause this now, and I'll finish in the next video.